every new beginning stems from the end of another. Let us go back to 2022, a year of glory when it comes to extragalactic astronomy. The year 2022 helped us get glimpses of the most distant galaxies and the farthest single star to date. This year was a year of breakthroughs in both astronomy and physics. Trust me, this is just the beginning. Stay with us till the end as we bring you the most mind-blowing breakthroughs of 2022. The farthest star. Let us start today's video with the farthest star discovered to date. Here we bring you Earendel, discovered by the Hubble Space Telescope. It might be surprising to hear that this star belonged to a rare population of stars that astronomers had been hunting for several decades. The distance between Earth and Earendel is about 12.9 billion light-years, and the present distance, considering the universe's expansion, is about 28 billion light-years. It sounds like the scientists have a lot to run. If you accept that the Big Bang was a true phenomenon, then it means that this star existed when the universe was just 900 million years old. It might be disappointing for the solar system, but this star is 8.2 billion years older than the Sun and the Earth. The star was initially observed by the Hubble telescope when it first observed its parent galaxy, which was gravitationally lensed by a cluster in the foreground. Surprisingly, gravitational lensing can magnify objects in the background by factors of thousands. With the help of this feature, the background galaxy containing Earendel appeared like an arc. The astronomers named this the Sunrise Arc. This team of astronomers also saw bright objects that were sitting on the edge of the distorted galaxy. Aren't you curious to know what they are? Usually, luminous sources in faraway galaxies turn out to be highly energetic events. Some examples of these events are novas, supernovas, or tidal disruptions caused by black holes. Well, objects like these tend to change their brightness with time, whereas Hubble's observation gave us the information that the brightness of this highly energetic object remained constant for over 3.5 years. This is how the astronomers concluded that they had found a gravitationally lensed bright star in the Sunrise Arc. Don't you think that sounds tedious? Since the Hubble had certain limitations that would prevent astronomers from learning more about the star, they used the James Webb Space Telescope in August. With the mission to study Earendel's properties further, astronomers discovered that Earendel is a B-type star, which has a surface temperature of 13,000 to 16,000 degrees. But here's the catch. This surface temperature is twice that of the Sun. Here's something more. This star has a jaw-dropping luminosity between 600,000 and 1 million times the luminosity of the Sun. Isn't this star an astronomical marvel? What makes astronomers so hooked on this star is that it could break the famous Humphreys-Davidson limit, or the HD limit. The HD limit in astrophysics can be defined as the impartial luminosity limit, above which no stars have ever been observed. This applies to stars in the local universe. In fact, if Earendel is proven to be a single star with 1 million times the luminosity of the Sun, the HD limit will have to be reconsidered and new constraints imposed. Another beam of light that excites us about Earendel's discovery is that this might be the first observation of a population of 3 stars that astronomers have been hunting for a number of decades. Yes, that's right. Earendel could be one of the first stars in the universe and could provide information about the nature of such first-generation stars. The restless Pluto. In the year 2006, NASA launched the New Horizons probe, and its mission was to explore Pluto, the dwarf planet. This probe travelled for 9 years and boarded Pluto, becoming 50 astronomical units, approximately 4.6 billion miles away from Earth. However, the data from Pluto is still being analysed by astronomers, even after more than 16 years since its launch. Well, 2022 gave rise to some information on Pluto that implied that Pluto is not as calm as we thought it was. The images received of Pluto's surface showed evidence of several bumpy volcanoes that were raised to various heights. What surprised scientists was that, unlike the rest of the planet, there weren't any craters due to asteroids or meteors nearby. Also, there was no evidence of plate tectonic activity here. On Earth, tectonic activity plays a crucial role in mountain formation. These factors hinted that this surface was formed as a result of a recent geologic disturbance, and astronomers believe that this could be a volcanic eruption. Beginning of the James Webb era. 2022 was a historic year, as this was the year when the James Webb era sprouted. The James Webb Telescope was launched on Christmas Day 2021. This $10 billion infrared telescope took about a month to reach its destination, which was the L2O Lagrange point. The initial images captured by this magnificent telescope were published on July 12th. They included the universe's deepest infrared images to date. Don't you want to know more about these images? The images included a detailed spectrum of an exoplanet's atmosphere, a stellar nursery where more than hundreds of stars are being born, a dying star with a ring of gas and dust surrounding it, and a visual grouping of 5 galaxies. What made the James Webb Telescope special and distinct from other telescopes was that, through it, people could view outer space with a clarity they had never seen before. According to the Big Bang, the formation of stars began about 150 million years after the universe began. Then, in the first 500 million years, these stars formed the first proto-galaxies. These are clusters of gas that clung to vast and invisible dark matter structures. What do you think formed the first galaxies in the universe? Yes, these proto-galaxies. Wormholes. 2022 was an important year when it came to the study of wormholes. Before getting into more detail about this, let's get a glimpse of what a wormhole is. Wormholes are objects that act like bridges that connect two faraway regions in space-time. They are believed to be hypothetical connections or shortcuts between regions within our universe. The thing about wormholes is that they could even be connecting two different universes. Welcome to the multiverse. If one such wormhole exists, then the entrance of a wormhole could be in one, while it could be in another. It's like bending space-time. You get what I mean, don't you? Based on theories, they could just connect billions of light years, or even short distances of a few meters. The initial concept of wormholes was proposed in 1935 by Einstein and Rosen bridges. In their paper, Einstein and Rosen discussed the possibility of a hypothetical bridge connecting two distant points in space-time. Interesting, isn't it? The fact is that they found such structures to be volatile if they were to be traversed. This time, a group of researchers designed a quantum circuit that is mathematically equivalent to an actual wormhole. Through this, they came up with a mind-blowing inference that wormholes and quantum entanglement are essentially the same. The Sagittarius A star. On May 12th, astronomers released the first picture of the supermassive black hole that was lying at the centre of the Milky Way. This black hole is located on the border of the constellations Sagittarius and Scorpius. The black hole is called Sagittarius A star. It is approximately 27,000 light-years away, and it subtends at an angle of just 52 micro-arc-seconds in the sky. It took several decades for astronomers to master the technique involved in producing this image. This is indeed quite a significant milestone in the history of radio astronomy and computational physics, don't you think so? An image of the accretion disk around the horizon of this black hole took about 5 years of calculations to process. An array of 8 radio telescopes collected the data at 6 different locations, and a huge sum of about 6,000 terabytes of data was produced. Well, if this were to be printed on paper, the paper stack would have reached the moon. When it comes to the shadow of a black hole, it is directly proportional to its mass. So when astronomers calculated the mass by analysing the black hole's image, it was a perfect match. 4 million solar masses. Once again, through this rigorous test, Einstein's general theory of relativity has been proved. Conclusion: 2022 paved the way for a multitude of astronomical breakthroughs that would be beneficial for the coming years. So what do you think about them? We have reached the end of this video, and I hope you all enjoyed it. We will meet you again in another interesting video. And until then, goodbye fellas.